Hey everyone, welcome to STEM Education with Olufemi. I'm Olufemi, and I'm absolutely excited to have you here today. My mission is simple but powerful: to make STEM subjects not just understandable, but genuinely exciting and accessible for learners everywhere, regardless of your background or experience level. Today, we're diving deep into Algebra Fundamentals, the essential building blocks that form the foundation of virtually every STEM field you can imagine, from engineering and physics to computer science and beyond. Whether you're just starting your mathematical journey or looking to strengthen your foundation, this video will give you the confidence and understanding you need to tackle algebraic concepts with ease. So let's get started. Algebra is a fascinating branch of mathematics that opens up a whole new world of problem-solving possibilities. Think of algebra as a secret code where letters stand for numbers. Instead of just working with known numbers, we use symbols to represent unknowns, allowing us to solve for them. Let's look at some examples of algebraic expressions. These are combinations of numbers, variables, and mathematical operations that represent unknown values. Here's our first example: 2x plus 3. The letter x represents an unknown number, and we're adding 3 to twice that unknown value. Our second example, y minus 5. Here y is our unknown variable, and we're subtracting 5 from whatever value y represents. And here's our third example, a divided by b. This shows division in algebra, where both a and b are unknown values, and we're finding what happens when a is divided by b. These algebraic expressions represent unknown values that we can solve for. Algebra gives us the power to find these unknown values and understand the relationships between different quantities. Remember, in algebra, letters and symbols are not just random characters. They represent real numbers that we can discover through mathematical reasoning and problem-solving techniques. In algebra, we work with two main types of mathematical components: variables and constants. Understanding the difference between these is fundamental to mastering algebraic concepts. First, let's explore variables. Variables are symbols that represent unknown or changing values. They act as placeholders for numbers we don't know yet, or values that can change. Common variable symbols include x, y, a, and b. These letters can represent any number, and their values can change depending on the problem we're solving. Now let's look at constants. Constants are fixed numbers that never change their value. They are the actual numerical values in our algebraic expressions. Examples of constants include positive numbers like 2 and 5, negative numbers like -3, and even special numbers like pi. These values remain the same no matter what. Now let's see how variables and constants work together in algebraic expressions. Consider the expression 3x plus 7. Here we can clearly identify which parts are variables and which are constants. In this expression, x is the variable shown in blue. It represents an unknown value that could be any number. The numbers 3 and 7 are constants shown in red. They are fixed values that never change. Let's look at more examples to reinforce this concept. Each expression contains both variables and constants, and we can identify them using our color coding system. Remember, variables are the letters that can represent different values, while constants are the fixed numbers. This distinction is crucial for solving algebraic problems and understanding how expressions work. Now we need to understand a crucial difference in algebra: the difference between algebraic expressions and algebraic equations. These two concepts are often confused, but they serve very different purposes in mathematics. First, let's look at algebraic expressions. An algebraic expression is a mathematical phrase that combines variables, constants, and operations like addition, subtraction, multiplication, and division. The key point is that expressions do not have an equal sign. Here are some examples of algebraic expressions. Notice that each one contains variables like x, y, a, and b, combined with numbers and operations, but none of them have an equal sign. They are like mathematical phrases, incomplete thoughts that describe relationships but don't make complete statements. Now let's examine algebraic equations. An equation is a mathematical statement that says two expressions are equal to each other. The crucial difference is that equations must have an equal sign, which connects two expressions and creates a complete mathematical statement. Here are examples of algebraic equations. Notice how each one takes an expression and sets it equal to another expression or number. The equals sign is the key. It transforms a mathematical phrase into a complete mathematical sentence that can be solved. Here's a helpful way to remember the difference. An expression is like a mathematical phrase. It describes something, but doesn't make a complete statement. An equation is like a mathematical sentence. It makes a complete statement that can be true or false. Just like in English, a phrase like the red car is incomplete, while the red car is fast is a complete sentence. Similarly, 4x plus 2 is just a phrase, but 4x plus 2 equals 10 is a complete mathematical sentence. The most important difference is this. Equations can be solved to find the value of unknown variables, while expressions can only be simplified or evaluated. When you see an equal sign, you know you can solve for the variable. Without an equal sign, you can only work with what you have. For example, the equation 2x plus 3 equals 11 can be solved to find that x equals 4. But the expression 2x plus 3 by itself cannot be solved. It can only be simplified or evaluated if we know what x is. Understanding this fundamental difference between expressions and equations is crucial for success in algebra. Remember, expressions are mathematical phrases. Equations are mathematical sentences that can be solved. Now we'll explore the 4 basic operations in algebra: addition, subtraction, multiplication, and division. These work just like regular arithmetic, but now we're working with variables and constants together. Let's start with addition. When we add terms with the same variable, we can combine them. Think of it like adding apples to apples. You can only combine things that are the same type. In algebra, 2x plus 3x equals 5x. We combine the coefficients, the numbers in front of the variables, while keeping the variable the same. Subtraction works the same way. When we subtract like terms, we subtract the coefficients and keep the variable unchanged. For multiplication, we multiply the number by the coefficient of the variable. 3 times 4a equals 12a. Division follows the same pattern. 8b divided by 2 equals 4b. We divide the coefficient and keep the variable. The key rule to remember is that you can only combine like terms, terms that have exactly the same variable part. 2x and 3x can combine, but 2x and 3y cannot. The goal of solving equations is to isolate the variable. That means getting the variable all by itself on one side of the equation. Today, we'll learn how to do this using inverse operations. To isolate variables, we use inverse operations. Inverse operations are operations that undo each other. Addition and subtraction are inverses, and multiplication and division are inverses. Think of an equation like a balance scale. Whatever you do to one side, you must do to the other side to keep it balanced. This is the golden rule of solving equations. Let's solve our first equation. X plus 5 equals 10. Our goal is to get x by itself. Since 5 is being added to x, we use the inverse operation, subtraction. We subtract 5 from both sides of the equation. On the left side, x plus 5 minus 5 gives us just x. On the right side, 10 minus 5 equals 5. Simplifying both sides, we get x equals 5. Let's check our answer by substituting 5 back into the original equation. 5 plus 5 equals 10. That's correct. Now let's try a multiplication equation. 2x equals 8. Here, x is being multiplied by 2, so we use the inverse operation, division. We divide both sides by 2. On the left side, 2x divided by 2 gives us x. On the right side, 8 divided by 2 equals 4. Simplifying, we get x equals 4. Let's verify. 2 times 4 equals 8. Perfect, our solution is correct. Remember the key steps. Identify what operation is being done to the variable. Use the inverse operation on both sides. Simplify, and always check your answer. With practice, solving equations becomes second nature. When we have mathematical expressions with multiple operations, we need to follow a specific order to get the correct answer. This is called the order of operations. We use the acronym PEMDAS to remember this order. PEMDAS stands for parentheses, exponents, multiplication and division from left to right, and addition and subtraction from left to right. Let me show you why order matters with a simple example. Consider the expression 2 plus 3 times 4. If we don't follow PEMDAS, we might get the wrong answer. Now let's try a more complex example that uses multiple parts of PEMDAS. We'll solve the expression 3 plus 2 to the power of 2 times 4 minus 1, step by step. Think of PEMDAS as a recipe for solving equations. Just like following a recipe in the right order gives you the perfect dish, following PEMDAS in the right order gives you the correct mathematical answer every time. That's it for today's Algebra Fundamentals. Let's quickly recap what we covered in this video. We learned about variables, the unknown values represented by letters like x, y, and z. We explored constants, fixed numbers like 5, -3, and pi. We distinguished between algebraic expressions and equations, understanding that expressions are mathematical phrases while equations show equality. We covered the 4 basic operations in algebra: addition, subtraction, multiplication, and division, and we mastered the order of operations using PEMDAS or BODMAS to solve problems correctly. Remember, practice makes perfect in algebra. The more problems you solve, the more confident you'll become with these fundamental concepts. If you found this video helpful, please give it a like. Your support helps us create more educational content. And don't forget to subscribe to STEM Education with Olufemi for more awesome STEM videos. Thanks for watching STEM Education with Olufemi. Keep practicing, keep learning, and we'll see you in the next video.